Session, and I'll also be the first speaker. I wanted to let all the speakers know that we will give you have 15 minutes to talk, and I will keep things on time. We'll ask you, give you a 2-minute sign, and if after about 16 minutes you don't stop talking, I will come join you. So be prepared for that. I'd like to thank everybody for coming, particularly with the room change and all the timing changes and making time to be here this morning. So I want to start my timer so I stay on time. Okay, so what I'd like to talk to you all about today is my long-term study on applied nucleation in tropical forest restoration. I wanted to synthesize some of those results. I also wanted to acknowledge many people who have worked with me on this project, in particular Zahawi and Leighton Reed, who are here at the meeting. And I also wanted to acknowledge for a few of you who might have heard Zach's talk yesterday or heard my talk at ESA, there will be a few slides at the beginning that are the same, but it will change after that. So you all know in the audience, and Katie Suding talked about it this morning, that there are ambitious tropical forest restoration targets. There are promises of hundreds of millions of hectares globally, and then other commitments like the 20 by 20 initiative, the Atlantic Forest Initiative in Brazil, that are promising tens of millions of hectares. There's a lot of debate about whether those are practical targets, whether they're all going into forest, so I won't debate that. But the big question is, how do we restore at this scale, given that we have small plot studies and we have limited resources? We know that one possible way to allow for recovery is natural regeneration, and a lot of work for people like Robin Chasden have shown that you can get a lot of natural regeneration in tropical forests, and so that should be our first choice. But there are also a lot of obstacles to recovery. There's lack of seed dispersal, there's stressful microclimatic conditions, there's these competitive pasture grasses, and this is a pasture in Panama after 10 years where there's almost no regeneration. So we need to start by assessing the natural regeneration, and then in some cases we need to intervene. The most common way to intervene is to plant trees at large scales. And that has been shown to have positive effects. It helps with dispersal of seeds. It also helps with shading out grasses, can help with nutrients. The problem is that it's very costly, and it also creates a very homogeneous conditions. So that got me and my colleagues to thinking about how do we do this differently. We know from ecology, there was a classic paper about 40 years ago that showed that what happens is in old fields is you usually get patches or nuclei of tree, they slowly spread and they coalesce. And this was written based on results from the eastern hardwood forest in the United States, but we know the same thing happens in the tropics where you have these patches of shrubs and trees that slowly spread. So that got us to thinking, well, maybe a good way to do restoration that's both ecologically and economically sound, if passive restoration is slow, and we know that plantations are homogeneous and costly, is that we would plant islands or nuclei of trees that facilitate recovery but provide more heterogeneity. So we've been collecting data for 13 years now on this study, and we've been asking questions, and I'll talk about a synthesis. Do they facilitate recovery? Is there a critical tree nuclei size? Do the nuclei spread? And are they practical to implement? The study site where I work is in southern Costa Rica. It's fragmented pre-montane forest. It's right here on the Panamanian border. It's fairly high elevation, or sort of medium elevation, and we get about 3 to 4 meters of rainfall a year. It was previously used some for coffee, and now there's a lot of cattle grazing. We established back in 2004, 2006, so over a decade ago. We had 16 sites, but at this point we have 13. The sites are separated by at least 1 kilometer with variable surrounding forest cover. I won't talk about that today because of time, but we haven't found a lot of forest cover effects. There are 3 treatments: natural regeneration, where nothing is planted; applied nucleation, where there are islands of trees, 4 by 4 meters, 8 by 8 meters, or 12 by 12 meters; and plantation, where the entire area is planted. We planted 4 species of trees, 2 that have some timber value, and 2 that are fast-growing nitrogen-fixing trees that provide shade in the coffee plantations. And then we cleared for 2.5 years, and then we let the system go. Just to give you an idea of what the sites look like, This is the plantations. In most cases, there's dense canopy cover, shades out the grasses quickly. As some of the trees die, we have a fair amount of seedling establishment. In our natural regeneration sites, these sites I took about a month ago, these pictures. In some cases, we still have very dense grass. There's the person there. And then you have occasional trees. In most of the sites, you have sort of patchy recovery, but not a lot. In the islands, this is a 3-year-old site, and so here's the islands. They're starting to spread, and then we start seeing that the canopy is starting to spread. So over time, they are starting to coalesce. I do like to point out when I'm talking that not all our sites look like that. There's a lot of variation across sites. This is one of our plantations here. There's some trees at the bottom, but not many at the top. And I emphasize that. I like to tell students it's very important to replicate your studies at many sites, any scientists, so that we can make generalities, because there's a lot of variability in what we find across our sites. We've collected a lot of data over the last 13 years. We've studied things like planted tree growth. We've also looked at seed rain, seedling establishment, nutrient cycling, mycorrhizae, epiphytes, birds, bats, and arthropods. And I won't talk about those all in detail, but a lot of those papers are available at my website if you want to know more about the details. I'm just going to summarize the results. So first of all, the first lesson we've learned is that applied nucleation and plantation restoration strategies seem to be similarly effective in enhancing the recovery of most species and functions. So I'm going to show quite a few figures like this. This is the response variable here. We have natural regeneration, applied nucleation, plantation, and then in some cases we have reference forest data. These are means plus or minus 1 standard error, and then these are Tukey's test comparing them. So first of all, these are data of latent reed. This is looking at frugivorous birds and bats. We find that after about 4 to 8 years that there seems to be the most in the plantations a little higher than applied nucleation, but they're not significantly different. They are higher than in natural regeneration. We have more data, and Leighton's going to be analyzing it next year, and I'm looking forward to seeing the later data. If we look, though, at seed rain, so on the top graph is small seeded species, under 5 millimeters, and on the bottom is larger seeded species, so over 5 millimeter diameter. These are data from about 6 to 8 years after establishment, that there's really, with the small seeded species, not a lot of difference across any of the treatments. It looks higher in the reference forest, but it's actually not significant, and that there's a lot of small seeded species dispersing in our landscape. But when you look at the larger seeded species, they're much higher in reference forest, but they are similar levels in the applied nucleation and plantation, and it's lower in natural regeneration. Then we add in here now on the right is the same graph, but this is the number of recruiting seedlings for the small seeds and the large seeds. And again, we don't see much different in the number of recruiting small seeded seedlings in applied nucleation, plantation, or reference forest. They're all pretty similar at this point. We do find that larger seeded species are much more common in the reference forest and then intermediate in applied nucleation and plantation. But in general, most response variables are very similar across these treatments. One more variable, and this is if you saw Zach Zahawi's talk yesterday. The pink shows this is leaf litter that's fallen and the biomass of leaf litter. The trends for nutrients are the same. If we look at the pink, which is after 5 years, we see a strong gradient of natural regeneration being lowest, applied nucleation intermediate, and plantation highest. But by 10 to 12 years after, we find that these values are very similar in applied nucleation and plantation and reference forest. So there's 2 points here. 1, applied nucleation does seem to work. 2 is that our results are changing very quickly over time, and we now have the luxury that we're starting to get more data that we keep collecting over time, and we can see those changes. The second lesson we've learned is that there is a minimum tree island necessary to enhance seed dispersal and seedling recruitment. And these are data from about after 3 to 4 years. This is the number of seeds per meter squared. This is the number of recruiting tree seedlings. These are in large, those are 12 by 12 meter, medium 8 by 8 meter, and small islands. And then these are different distances away from the planted area. And you can see that both for seeds and for seedlings, they're much higher in the large and the medium. they're not really that much higher in the small than going away from there. Our smaller islands just didn't seem to be that effective. And one of the reasons we think for that is because we had a student who did work that we found that the small tree islands were less likely to be visited by birds, and also they tend to be less likely to shade out the grasses. So I don't have later data on the islands because over time they've all changed sizes and they've sort of coalesced now, so I can't really say at this point that there are small, medium, and large islands. Which gets me to our third lesson. We found that originally tree island cover has expanded rapidly. We planted less than 25% of the area, but now in most of our sites, the tree cover is over 50%. And so we have these tree islands that are expanding partly due to the growing canopy and partly due to recruitment along the edges. This is from a drone flight that we did, with the blue being short and the yellow being taller. So this is obviously the plantation. This is the natural regeneration, and you can see the islands starting to slowly merge over time in those canopies. They're not really that separate anymore. I do like to point out that the results I'm talking are about from our system, and there are starting to be more nucleation studies, and it may work in some cases and not in others. In contrast, this is a study of Jose Maria Rabanillas in Spain, where he planted islands in an oak woodland, and then they went out about a couple years ago. It was after 21 years, and you can see that these tree islands haven't spread at all. The few recruiting seedlings are these blue dots here. And the reason is, after doing some studying, is because there's really heavy herbivory at the edges of the islands, largely due to rabbits and other small mammals. And I just like to make this point to say that our results don't necessarily generalize everywhere else, and so we're starting to learn more about this approach in restoration across studies. The fourth lesson that we've learned is that there are some logistical and social challenges to applied nucleation. It seems to work ecologically. The costs are reduced because the costs are scaled to the area you plant, so they would be a quarter of the amount if you plant a quarter of the area. But one of the problems is the regular planting design. It's harder to clear around the tree seedlings. We had slightly more damage to the seedlings when they were macheting around them because they're not in straight rows like most plantations. Another problem with applied nucleation, and this is also true sometimes with natural regeneration, is it looks a lot messier. And so landowners, there's this sort of neat, okay, trees are planted in rows and it shows who owns the land, and so we've had some resistance with that issue. And then the other issue is when you have open areas that aren't clearly claimed by trees, which is also, again, true in natural regeneration, you can have concerns about people putting their cows in there, or potentially in another system, fire risk. We don't have a lot of fire problems, but there are some, it's not just about the ecological question, but there's definitely some social questions that need to be overcome. So in conclusion, we think that applied nucleation, or at least the results from our study, suggest that applied nucleation is a cost-effective restoration strategy that simulates natural recovery. And like I said, the costs are scaled to how much of the area you plant. We found that larger islands have several advantages. They're just easier to manage, they attract more birds and shade out grasses. But we really feel strongly that applied nucleation should be tested more widely when it's consistent with restoration goals. And it's exciting that there are more studies coming online. There's actually a couple later in the session that are talking about it. And we've actually started collaborating with some other people on studies. My collaborator, Zach, now has a study in Colombia, and I was actually here early before the conference because I'm collaborating with Pedro Brancaleon at the University of Sao Paulo, and he just set up a big study around Piracicaba looking at nucleation. And what we're doing there is that he has two sites, 17 hectares and 25 hectares, with pretty large plots. At the one site, they're 1 hectare plots, and at the other site, they're half-hectare plots. And what we're looking at is the planted area is in green, using tree nuclei or islands in 25% of the area, also in 50% of the area. But he felt that a more practical approach might be to plant in strips, because a lot of the planting that's done is in lines rather than patches. And so that might overcome some of our problems with lines. And so we have these 25 strips and 50%, and then planting the entire area. And so this was just set up about 3 months ago, so I guess we'll need a few more years before we can actually tell you what we found in that study. So in conclusion, I'd like to acknowledge my funding sources, particularly the National Science Foundation. It is very hard to get funding for long-term studies, so I'm pleased to still have some after a decade. We're really excited to be able to continue monitoring because there are so many short-term studies in restoration. Again, a lot of people worked on the project, and if you want to see any of the publications, there's a lot of them on my website, or I'll be around for the next few days, and you can talk to me. So thank you very much, and I'd be happy to answer any questions. Are there questions? Okay, cool. Yes, Carla.
Yeah, Karen, I was just wondering about the sampling strategy for all of those attributes in the island plots, because they're heterogeneous, you know. The other two kinds are homogeneous, but depending on the, you know, how you sample, are you sampling only in the tree islands, or are you sampling across both the islands and the non-tree habitat within those plots?
Very good question. Yeah, it depends. So our ongoing seedling recruitment, we have we go from the islands kind of out towards the edge. The idea originally was to kind of look at the edge, but now the edge are sort of expanding in different directions. So sometimes the edge is entirely in the island, but yes, it was purposely set up to go across the edge when we're sampling within the plots. At this point, for a lot of our, we're very conscious of that. We try to proportionally sample, say, soil or other things, proportionally to the area planted versus the area outside. We aren't doing any more analyses within the plot that much because the islands have moved so much that all our analysis, our statistical comparisons are at the plot level. But yes, we try to do that. And like things like birds, you pretty much, the size of the plot, you have to sample the entire plot to do that. But yes, we do that. We actually, our annual vegetation sampling, we do a little bit higher in the islands to try to get at that heterogeneity. But when we've done straight on heterogeneity comparisons for a couple of our snapshots, we have actually increased the sampling so that it's equal across all the treatments so that it's comparable. Yeah, Carol.
Karen, what do you think, would it be possible to apply this approach to temperate or boreal forests? What's your opinion or experience?
Well, it's really interesting to start learning about more people who are doing this. The long-term studies that I know about, yes, I think it could. I think it's also really likely to work well in shrublands. They have different mechanisms of facilitation where it might be more moisture. I learned about a study recently where they're doing it in salt marshes because it reduces salinity. One of the most interesting long-term studies in temperate forests is work of Steve Handel, who's here, and then another person, Jeff Corbin, a colleague of mine, who followed up on his study at Fresh Kills where he did that. And they actually found it worked pretty well. There wasn't as much concentration of establishment near the nuclei because a lot of their plants were wind dispersed. In tropical forests where I work, it's 80%, so the nuclei are particularly effective. But yes, I do think that there's a range of systems it could work in. I think the mechanisms are kind of different, and I think it'll be interesting to see in a few years as more studies come out, you know, if we can start to come up with some generalizations of when it does work or when it doesn't work. Because I showed that case from Spain where it doesn't really seem like the islands are spreading, and that's one of the big keys to it. Other questions? Yes?
Yeah. So there's quite sound evidence that this works where you have remnant vegetation, native vegetation, but can we apply the nucleation in large landscapes without any remnant native vegetation?
That's a really good question. I didn't talk about this, but we have not found much landscape cover effect. And we were really surprised about this because everybody thinks landscape's so important. And the reason that we think it might not be in our landscape is that we have a lot of living fences in our landscape. There are a few remnant patches. There's a lot of trees in the pastures. I don't have the picture up there to show that. But we do have a lot of trees. And so we think that we aren't seeing that because there are so many trees in the landscape that are sources of seeds. We're doing more individual seed mapping now to figure out the patterns like, okay, if our oaks limited, well, where are all the oaks, say, for instance, landscape. The landscape where we're working, where Pedro's working, at least one of them is pretty low on forest cover, and so I think we would need to think more about whether it works in low-cover landscapes. I don't know that it would be any less effective than plantations, but hopefully this new study in Brazil and with some other studies we can get at a sense of how important the landscape is. But like I said, we haven't seen many landscape effects so far because we have some pretty low forest cover within an individual landscape sites. I think that we're out of time, so I'm gonna, I'll be around, and I'd like to introduce our next speaker, or can we get the next presentation, please? Our next speaker is Maximilian Cardoso Ferreira, who will be talking about topsoil translocation for tropical dry forest restoration. So I'll pass.
Passa para cá. Ok. Good morning. Trouxe uma colinha aqui. Good morning, my name is Max Miller. I am a researcher of Cerrado Restoration. I got my master's degree in ecology at Brazil University, advanced by Daniel Vieira in Brapa Genetic Resource. And I will present some results my master's did. I do not speak English fluent, como vocês viram, but will try pass the message at best I can. This study, my study work titled Topsoil Translocation for Tropical Dry Forest Restoration, Resprout Root Fragments and Germination Pioneers Tiger Forest Regeneration. Vegetative regeneration in dry forest is an attribute selected per dry season. Which might cause the lost plant aerial parts it will sprout after the dry season. And by the occasional fires coming from neighboring pyrophytic systems, such as tropical savannas. Plants, but resprout after the slashing burn for agriculture, practically has been used in tropics over the millennium. He sprout after stump removal. He sprout after the plough soil. This forest presents a transient seed bank that stocks during dry season and germinates in the wet season. Dry forests are usually suppressed for limestone mining. In such case, the vegetation and topsoil are removed and discarded in waste piles, preventing the potential use for regenerative purpose. However, this material can be translocated to restoration sites. The topsoil needs to be removed and translocated right after because of the bud banking roots and stems decay and the seasonal seed bank. My goal of this study was evaluate the natural regeneration in recovery area what received topsoil from seasonal deciduous forest. Specific, evaluate the mechanism involved in natural regeneration, wood species richness, density, and coverage of plant life forms, and the effectiveness of different topsoil deposition techniques. For this, treatment will down and deposition, and 3 deposition layers, leveling in 20 centimeters, leveling in 40 centimeters, and mounts, will down leveling. This is located in Federal District, Cerrado Biome. Severe dry forest spots occur in regions with more fertile soils. This is the studied secondary seasonal deciduous forest. Deforested for limestone mining expansion. Forest is clear cut in May, and about 30 centimeters of topsoil was removed in November. The deposition area used to be pasture dominated por Andropogogaianus urucloda cumin grasses. Deposition area was scarificated to lose soil and remove grasses. Topsoil spreading, mounds deposition, leveling in 40 centimeters, leveling in 20 centimeters. Suppressed vegetation and seed bank sample was in May, and topsoil stripping spreading in November. I measure source of food regenerative species and the emergence deep of sprouts. So we measured the distance between soil and sprout organ. These were the months I sample vegetation cover and richness and dense species. At 28 months, deposition treatments did not differ among themselves, but differ from area, wilt down, and deposition. The deposition treatments showed 51 species of trees, 8 lianas, 12 scrubs, and 34 herbs. Deposition area with bare soil. The same area 6 months after with herbaceous scrub domain. The same here after 12 months with herbaceous scrub domain and juvenile tree growth. After 28 months with tree hind season and early secondary forest formation. Wilt down deposition with bare soil. After 6 months, scrub domain. After 12 months, Andropogogaianus recover. And after 28 months, pasture is in stable state, recover. Contrast at 28 months, 28 months, wilt down deposition, topsoil deposition. Okay. Ruderal herbáceo scrubs originated from seed bank transferred from topsoil. 74% of trees and 60% of lianas were sprouting. Other trees and lianas changed for seed high. 41, 42. Root fragments transferred from topsoil were the main source of sprouts. E sprouts produced vigorous new roots, alcançando rich autócthone soils. Resprout emerged from the first 20 centimeters of deposition topsoil. The red mark shows the resprout emergence point in soil. All three deposition treatments brought similar change in vegetation cover and were equally different from control treatment. The proportion of bare ground decreased to 0 in second 28 months due to a 76% increase in coverage of ruderal herbáceo scrub and 8% of wood species. Exotic grasses in relow deposition recover their dominance, reaching for 98% cover. The number of species and density of trees are the same for all deposition treatments, but differ the control. 14 for species versus 5 species. Deixa eu... 45. In this study, 3 groups of regenerates composed the forest recovery process: ruderal herbs and scrubs, seed bank; pioneer trees and trillets, seed high; and resprout trees and lianas. Herbaceous scrub species that germinated from seed bank quickly cover the soil and attract dispersal of forest pioneers, Trema micrantha and Cecropia paxitaceum. Root fragments sprouted, bring to area severe species of trees and lianas present in topsoil of the source forest. Bauhinia, Dilodendro, Guettarda, and Sebastianium. The 3 groups of regenerates cause a compact process of forest recovery, thanks for topsoil resilience and seed high from adjacent landscape. Based or findings, we suggest the deposition of 20 centimeter layers of topsoil because of the similarities between deposition treatments in wood species, thickness, and density, and vegetation cover life forms. Besides that, resprout do not emerge from depths greater than 20 centimeters, and seed germination is concentrated in top 5 centimeters of soil. Thanks to our attention, this is the paper this study. The other paper in Savannah. Now UK make questions. I need help for translation. Agradecemos as instituições. E this is the group de research que trabalhamos, Restaura Cerrado. Votem na gente lá no offset do programa do Congresso. Obrigado. Thank you. Se for em inglês, vocês dão uma forcinha aí, hein?
Que tamanho médio eram esses fragmentos de raiz? What was the size of these root fragments? The minimum size for them to germinate? The cuttings.
Vou responder em português, vocês podem traduzir para inglês. A gente mediu isso no trabalho e a gente transformou em volume. A gente mediu o comprimento e o diâmetro médio de cada fragmento. E a gente percebeu, a gente visualizou com os dados que os fragmentos que tinham entre 100 centímetros cúbicos e 1.000 centímetros cúbicos é o que apresentava o maior potencial de rebrota. No conjunto total de fragmentos, apenas 0,7% dos fragmentos rebrotaram, mas gerou essa grande quantidade de indivíduos. Só que os fragmentos que tinham entre 100 e 1.000 apresentavam 19% de rebrota. Então, os pedaços que tinham mais ou menos esse tamanho, 19% rebrotava. É bem. Só que como o método é muito destrutivo, né, na hora de remover o solo, muito das raízes são picotadas, né? Então, se a gente conseguir melhorar na hora da remoção, para os pedaços ficarem maiores, o potencial de rebrota pode ser ainda maior.
Obrigado.
Valeu, Daniel.
We've digged a cubic square meter to count all the pieces of roots, and we have thousands of pieces of roots, but only the big species resprouted. 20% of the big pieces of roots resprouted, and the rest just didn't sprout. But even so, with this low level of resprouting, we got 1.7 seedlings per meter square. We can improve the excavation method to use bigger pieces and to improve resprouting ability.
Ok. Tem outra pergunta lá.
Oi, desculpa, eu não sei se eu perdi algum pedaço no começo. Você remove esse solo, topsoil, de onde e se isso, qual o impacto que é gerado na área de origem desse topsoil?
Tá bom. Eu acho que eu falei no começo. A ideia é aproveitar esse material quando a vegetação for ser desmatada. Uma ferrovia, uma estrada, área urbana, expansão urbana e mineração. Quando vai ter essas expansões de cava de mineração, o topsoil é removido. Só que muitas vezes ele é o primeiro a ser descartado na pilha de rejeito. E aí o subsolo vem jogado por cima. O que a gente propõe é separar o topsoil e depositar em uma área de recuperação. E essa é a condição. Existem algumas pessoas que retiram de áreas nativas em pequena quantidade. A gente não sugere isso no trabalho, a gente sugere usar o topsoil quando ele for removido para ser descartado. E isso existe muito no Brasil, em área de mineração e com a expansão de ferrovia, expansão usina hidrelétrica. Tem várias situações que a gente pode aproveitar esse solo.
She's asking if what's the impact of excavating the soil to translocate to a restoration site. But in this case, it was an excavation to mining, so it's garbage. It's just a stockpile, and then we are just using this to restoring. So it's free, and it used to be just garbage in federal district. And you can use this not only to mining, but you can use when you are building roads or hydroelectric dams, kinds of.
Ok.
Caso esse topsoil não possa ser usado imediatamente, quanto tempo você acha que é viável deixar ele estocado para usar depois?
Essa é uma boa pergunta. Como a gente está lidando com potencial de rebrota, a gente deixar ele estocado muito tempo, principalmente se chover, pode forçar essas raízes a rebrotarem na pilha de deposição. Inclusive, elas podem apodrecer. Mas a gente acredita que algo entre algumas semanas e, no máximo, 1 mês e meio pode não atrapalhar esse potencial. Até porque a gente depositou o topsoil e as plantas, de fato, foram rebrotar 2 meses depois. Então, a gente tem uma lacuna de tempo aí que a gente ainda tem que testar. Mas, baseado nisso, a gente acredita que, no máximo, uns 2 meses. Depois, esse potencial de rebrota pode se perder. E a mesma coisa acontece com as sementes, porque se elas ficarem muito enterradas, elas podem apodrecer. O que a gente acredita é que, para melhorar o método, a gente tem que operacionalizar bem essa remoção do solo, desmatar a vegetação no final da seca e rapidamente já transpor o topsoil, para evitar que esse potencial de rebrota se perca e também para aproveitar as sementes que estão disponíveis nessa época, porque essa vegetação acumula a dispersão no final da estação seca. Então, tentar operacionalizar para poder aproveitar ao máximo esse potencial regenerativo que é do ecossistema para além do topsoil, né? Tem muito potencial propagativo nas raízes e nas sementes da vegetação.
So I'd like to
Okay, good morning. My name is Fernando Bechara. I'm a professor at the Universidade Tecnológica Federal do Paraná. And I may give you a Brazilian subtropical rainforest restoration. In this presentation, we are comparing passive methods and applied nucleation, but it's another system. It's not a system of nucleation like Karen Holl presented. It's more granular, not plantation islands. But anyway, let's do that. So if we consider this SER definition, ecological restoration seeks to assist recovery more than impose a new direction or form. So that's what we are talking about. I think it's very important to consider that. So in this paper, we detect 3 different phases of recovery. The first phase would take at least 20 years to almost 200 years, and it would recover just the structure. If you consider the composition, species composition, it would take some hundreds of years, depending on the conditions of the area. And more than that, if you consider a third phase, where you recover rare and endemic species, it could take, depending on the area, some thousands of years. So what I mean here is that the succession process is really slow. So we should respect that if you want to have a good ecological restoration. So sure, it's urgent to restore, but we should consider this natural pace. So we are here in Paraná State, in Atlantic Forest. We are in a subtropical forest with 2,000 millimeters a year of rainfall. So, and the difference here is that we have frosts. We have at least 1 frost per each 2 years. And that definitely hinders the succession. So here it's a kind of slower, the recovery, if you compare to other tropical areas in Brazil. So here our experiment, we have a 7 hectares experimental area where the former land use were crops and pastures. So before putting the treatments on field, we did a clear cut. We clear all the area so the treatments would have the same chances to develop. So here an image. So we are testing 3 treatments. They are the same treatments that Holl is testing, but our nucleation system is kind of different. I will focus this presentation on these methods. And our plantation system is more kind of different as well. So here you can, at 6 years, you already can notice clearly difference between the treatments. Here are the plots. Okay, they are about 1 hectare per treatment. So here before and 6 years after, in a passive restoration, where we just remove the disturbance. The plantation, we are using the Ricardo Rodrigues method. So we have a high diversity of seedlings of 10 filling species that are fast-growing shading trees, and 60 diverse species that are slow-growing trees. So we have 70 different native tree species all together in the same site. So the idea is that the fast-growing would shade the slow-growing ones. Some pictures of the implantation in lines, 3x2 spacement meters. So 1.5 years and 3 years after, we maintained a clear cutting and removal of weeds and other competitors up to the 3rd year. So here a picture of the plantation system 6 years after. So you can see a very well done, very closed canopy with different species. So I'm going to focus here on these nucleation methods that are kind of more complex. So I will give you some of this. How do you do that? Okay. So it's a paper published with Catherine Sudden in Berkeley's group. Here we have different techniques that would provide, the idea here is to provide promote a higher niche heterogeneity. So we are talking, you're using seed rain, topsoil, perches, and artificial shelters for animals. We do the bromeliads also. We don't just plant trees here, but other life forms. Okay, but I've been talking about each one now. So it's our nucleations. They are on strips, like Holl is going to test now, but they are kind of different because they are applied in spots. I mean, it's a more ink spot strategy. I mean, the techniques are put all together on the strips. So the idea here is that with time, with successional time, it's slow, these strips would spread and recover the whole area. Okay, so here a picture of these strips on field. So I'm going to talk about each technique of this nucleation technique. So we have a donor area where we are going to borrow small pieces of topsoil. They are 1 per 1 square meter, so it will not impact the donor area. So here we put this material on the nursery. We don't put, because it's small pieces, so we're gonna have more germination here. So we don't use direct on the field. We pass first on the nursery. So here you have a lot of biodiversity, not just plants, but also microbiota and other fauna, soil animals. So here we produce these sods and put on the field, and some years after we have nuclei. So 2 years and 4 years after we have a nucleus on the field. The seed rain is kind of the same system, but instead of collecting the seed bank, we are going to collect the seed rain now. So different elements of a forest, okay? So we have seed traps, and every month we go to the seed traps and collect the seeds that are in the seed rain. The interesting here is that as you go every month along the year, we will have the phenology considered. The species that we put on the field, they will have fruits in all months of the year. Okay, so it's very important to fauna maintenance. We expect that. So here, same thing on topsoil. We put on trays. We produce sods of high diversity and put on the field, making the nucleus after some years. We still use the artificial perches. We like this technique put together with the artificial shelters. There are pilewoods here, so the birds can go up and down and have more food so you can attract more birds because you are providing foods besides a perch. Okay, so we consider that a cheap technique that is good to put when together with other techniques, not just to restore a pasture land, because it would not be effective in that way. So here we use also cover crops, especially nitrogen fixers. We are using pigeon peas, but we can use many species. The interesting thing is that you can attract the pollinators besides putting nitrogen in soil. So they have flowers very rapidly, and you can attract the pollinators. So we put seed rain, seed bank, perches, cover crops. Now we are going to put bromeliads that are a life form that is very important in forest restoration because they have the tank function to storage water. So we consider that very important when you are in a process of restoration of a degraded area. Okay. And besides that, these species that we use, they kind of spread, making a natural nucleus that will function like a natural shelter for many animals and attract many animals also by its fruits. So we want other kinds of animals, so we make artificial shelters with any wood debris and put it in form of piles that with time, with succession time, it will be kind of integrated with the understory, and so it will be very effective for many kinds of animals of different size. So we plant trees also, but we don't do that on the whole area. In lines, we put that in dense nuclei that all spread for the area. So the idea here is that we use around one third of the seedlings that we would use in a traditional plantation system. And that's definitely where you make this nucleation system cheaper than a plantation system that you would have to take care of 3 times more seedlings with fertilizing and removing weeds, etc. So here the tree islets 2 and 4 years after, okay, producing nuclei. And here we have a before and after, 6 years after. You can notice the nucleus formed on the plot. Oh, sorry. Here. So if we consider the phytophysiognomies, we can notice a structural gradient between the passive restoration, that would be more a shrubland, more a natural formation after 4 years here. The plantation system is the opposite. You have a taller trees, a canopy well formed, and the nucleation system is an intermediated system between both the passive and the plantation. Okay. So here a picture of all the plots. You can again see some passive restoration failing. Here plantation, nucleation. So they definitely have different responses on field. I will not focus this presentation on data, but I will, because the next presentation is my grad student, Bruna. She will give you the vegetation monitoring data. Here I want to focus just on even fauna. We have others monitoring soil, monitoring fauna of soil, monitoring birds, and anyway, I will give you an example here. The birds at 2 years old, we detect 17 exclusive species to each treatment. I think it's really important because my point here is that the different techniques would bring different diversity for your area. If you use one technique or other, or one treatment, plantation or nucleation, you attract a different biodiversity for your area. So I consider that very important. So to conclude, I would like to say again that we should respect more the slow rhythm of the succession. We should not be in a hurry to have the forest, to recover a forest, to have our old growth forest. So it's successional time. And to assist to recover, we are recommending now that we can use an integrated system, a mix of nucleation and plantation. So you could bring the advantages and the disadvantages of each technique and put it all together. So the plantation system will attract some kinds of birds, some ecological groups of birds and other animals, and the nucleation system will attract other functional groups. So why not put it all together? And depending on the situation of the degradation of your area, you can put a more labor-intensive nucleation or a less intensive, or a more labor plantation or not. So that's my conclusion. We could put, why not, these different technologies together to work to attract more biodiversity. Thanks. If you have some words, some questions.
So I guess I have a couple of questions. One was you said that nucleation was cheaper. And in our case, we plant only so it's scaled to the amount of area planted. You talked about 6 different techniques. So if you did all of those and you collected seeds every month, it seems to me like it would actually be quite expensive. Have you done the calculations to compare all those different methods and then to compare those with the cost of planting?
Yes, that's a good question. And when we begin to work on that, we were thinking about it. We thought nucleation is a much more complex system, so it would take much more labor and it would be more expensive. But on the field, on the beginning, if the workers were kind of confused to put on the field, but after you have your workers well trained, it starts to be cheaper. So my answer for you is that you have to have a very trained worker staff to do that. So if you have that, and we achieved that, so it will be much faster to put 1 hectare of nucleation that put on a plantation system, because nucleation has less labor in planting seedlings. Okay, so the next presentation, my grad student Bruna, she will present you some costs. She's doing exactly that, comparing costs. Thanks.
Thanks.
How long do the topsoil sods and seed range sods, how long do they stay in the nursery before you bring them out to the field?
Okay, it depends on your demanding of seedlings, but I would say it would remain in the nursery about 3 to 6 months. You could maintain that on the field. We just don't know about the soil biota, how much they could remain on the sods. We are not monitoring that still. Okay. What's up?
They stay for 6 months in the nursery with irrigation before you take them out?
Yep. As I told you, from 3 months to 6 months. It depends on your demand. Okay.
Other questions? Anybody? Then I'll ask another question. Well, could you social acceptance? I talked a little bit about some of the social obstacles. It seems like you have that one site. Have you worked with numerous landowners to get a sense of whether this is really practical from the landowner perspective? To actually implement this at a large scale, I can see it might be a little bit hard. We just plant trees, and that's difficult enough to do the patches. And with your strategy, have you done this at other sites, and can you talk about how the landowners feel about this method?
I see. We have another experiment, nucleation experiments. I did it in my mastering and my doctorate, but they are more not in this experimental design. So in that experimental design, we just have this area. We have 4 blocks with 4 replications of each treatment, but I definitely know that it is not enough. You should test that in other sites also to compare. That's what.
No, my question was, how do people feel about it? Like, have you worked with actual landowners outside the experimental station to see if they would accept this type of approach? Because it's very different from a tree planting approach.
Yeah, it's really
that's my question.
Yeah, it's really difficult to be accepted because it's more complex. If you tell the company or the land manager to plant rows of lines and rows of trees, it's much easier. They would accept that it's much easier to be acceptable. So definitely, I think the nucleation system demands a much more developed human resources to put it on field, to think about the design and put on the field. I think it's more, definitely more complex.
Okay, we're out of time.
Thank you.
So we'll go on to the next topic. We'll be hearing from Bruna Elisa Trentin, who we just heard will be talking about an extension of this previous study and showing us some data. So, thank you.
Okay. Good morning. My name is Bruna, and I am a master's degree student at São Paulo State University. My advisor is Professor Vera Alex Engel, and my co-advisor is Professor Fernando Bechara. So my presentation is entitled Subtropical Mixed Rainforest Restoration. Are nucleation techniques sufficient to promote recovery of plant biodiversity? So basically, nucleation consists in the use of vegetation nuclei that will promote an ecological flow between nature and the implanted nuclei. So we wanted the result of an ecological succession over time. This study had mainly 3 questions. The first question was, has nucleation lower costs when compared to high diversity reforestation in total area? The second question was, does nucleation produce a more similar result to a natural succession or passive restoration than reforestation? And the third question was, is nucleation effective in inhibiting the presence of invasive alien species? So the study site was located at Paraná State, more specifically in this spot. This is a satellite image of the area, and here we have the plots. And I brought this image because you can see the landscape around it. So we had a lot of crop and pastures, but we still have a forest remnant right here. So here you can take a closer look to the plots. So we had 4 randomized blocks with 3 treatments, with a total of 12 plots. Each plot had 40 by 54 meters. So this is the image of one plot. And for sampling purposes, we subdivided into 6 strips, with a total of 2.59 hectares for all the plots. So the first treatment was a mixed reforestation with native species, infilling, and diverse lines. Here I called it REF. So we used filling species and diversity species intercalated in the rows and between rows. The spacing was 3 by 2 meters. And we used 10 species for filling and 60 species for diversity. The second treatment was nucleation. I called it nuke. And we used it in strips, as Fernando just said. So each plot had 6 strips, spaced by 6 meters. And each strip had a combination of nucleation techniques. So one of the techniques was the topsoil. Each strip had 1 topsoil. Then we used 3 islets. We used 12 species for filling and 24 species for diversity. Each strip had 4 groups of 3 islets. We also used cover crop. So each strip had 2 cover crops. And we used bromeliads. This first strip had 2 nuclei of bromeliads. And we also used seed rain. So each strip had 1 seed rain. The difference between the strips was in the middle. So this second model had artificial shelters and also artificial perches. And the third model had 1 artificial shelter and 1 bromeliad. The passive restoration treatment consisted only in area isolation, and so natural regeneration could happen. So all the treatments included 3 years of maintenance. So to sample the plants, I did a phytosociological survey, and I sampled all the plants taller than 50 centimeters, except grasses. So I counted all of them, and also we identified So we also separated all the individuals as planted or regenerated. This sampling happened 6 years and 3 months after implantation. And we evaluated 3 strips of 40 by 9 meters, which is a total of 50% of the area. So to measure invasive species coverage, we used the line interception method. And we consider it as invasive species, all the grasses, and also these species called Arachis pintoi, which had an invasive behavior in our plots. We also calculated all the implantation and maintenance costs. Some of the results. So we also classified all the species founded as life form. And here we can see, in passive restoration, the most of the species were herbs, followed by lianas, and then trees. In nucleation, we had most of the species as trees, followed by herbs, and then shrubs. In reforestation plots, we had most of the species as trees, followed by shrub trees, and then herbs. We also classified all the species for dispersal syndrome, and we could find a pattern in all the treatments that was the same. So all the treatments had most of its species as zoochoric, and then anemochory, followed by autochory. Regarding plant density, we separated in regenerating species and then planted species. So when looking at regenerating species, reforestation had the higher density of individuals, and nucleation had the lowest. When considering planted individuals' density, there was no difference between nucleation and reforestation. Looking at richness, when considering planted plus regenerating individuals, we had nucleation and reforestation with the higher rates of richness, and passive restoration the lowest. However, when considering only regenerating individuals, nucleation and passive restoration had the highest richness, and reforestation the lowest. Looking at the Shannon Diversity Index, for planted and regenerating individuals, and also for only regenerating individuals, we had the same pattern. So passive restoration had the higher Shannon Diversity Index in both cases, and reforestation the lowest. However, when looking to Fisher's Alpha Diversity Index, there was no difference among treatments for both cases. Looking at this MDS using density of species, we could see the formation of 3 groups regarding the plots. So each treatment formed a different group. However, reforestation plots were more closer together. Looking at invasive species coverage, we could see that nucleation had the highest invasive species coverage and reforestation the lowest. So we wanted to see if plant density had an influence on invasive species coverage. For both treatments of reforestation and passive restoration, we didn't find that plant density influenced on invasive species coverage. However, on nucleation, we did find that plant density influenced invasive species coverage. So when we had the lowest numbers of plant density, we had the highest invasive species coverage. Same happened for observed richness. So we didn't find any influence of observed richness in invasive species coverage for reforestation and passive restoration. However, we find that when we had lower numbers of richness, we had the highest invasive species coverage on nucleation. So talking about the costs, I just brought a summary of these costs because I have it all in my dissertation. So the implantation costs for nucleation were about $4,000, which is higher than reforestation. That was only $3,600. However, the maintenance costs for nucleation are lower than reforestation. So in nucleation, the maintenance costs were about $2,000, and for reforestation, we had about $4,500. So the total cost of nucleation per hectare was about $6,000, and for reforestation was about $8,000. For passive restoration, we did consider any implantation costs because we are not considering fences. So we had some maintenance costs because we did some maintenance in all the area, which included passive restoration plots. So this was about $400. So we can see here that nucleation was 26% cheaper than reforestation. So some conclusions. Invasive grass cover was higher in nucleation and tended to be higher in passive restoration plots. And it probably happened due to the longer time for canopy closure in these plots. So the nuclei did not seem to be large enough to promote grass suppression and native plant regeneration. So as nucleation had similar results when compared to passive restoration, this second option could be a good option in this area. However, it depends largely on the landscape context in which the site is inserted. And despite the higher costs, reforestation was efficient in promoting regenerating density. So an implication for practice, we suggest a combination of techniques, including nucleation, maybe using larger nuclei, and plantation to promote biodiversity, recovery, and with lower implantation costs than reforestation. Thank you so much.
So maybe I'll start with a question. Did you compare the species composition to any sort of a reference forest to look at which one was better approaching the nearby forest?
No, we didn't do that because the forest remnant that we have closer is not it's a secondary forest, so it's not in a good condition to compare. So we didn't do that yet.
Okay, I saw a question in the back there.
Thank you. Congratulations on the presentation. It's very nice to see such good work by young researchers. That's really nice. But I wanted to question, continuing Karen's question on the last presentation, what was the cost of maintenance for the reference treatment? Why is the maintenance was so much higher in the reference systems? What did you do?
Okay, why it was so high in reforestation? Okay, so basically we applied a herbicide in our area for plantation during 3 years, and as nucleation was implanted only in strips, we just care about those strips. We didn't make any maintenance outside those strips. So nucleation was applied only to 9% of the total plot, so it's a smaller area than reforestation. And we have less trees, so we don't use as much fertilization and other stuff. That's it.
Other questions?
What kind of herbicide did you apply?
Glyphosate.
Any other questions?
It was kind of weird for me to have your conclusions related to passive regeneration. That in your conclusions you're not putting these as a preferential solution.
Yeah.
Of course, you're dealing with this density and diversity factors, but don't you think that considering the need for having large-scale regeneration, this technique could be a solution?
Yeah, so I focused on nucleation because of my goals, and so I really wanted to know if nucleation was good enough and we could use it in large scale. So I didn't focus on passive restoration, but yes, our results were really great for passive restoration.
I got a question here. Were there any invasive tree species or just like herbs and grasses?
We also had a species called Ovenia dulcis, that it was invasive in our plots, but we did it as a maintenance. During the 3 years, we removed that species, so it didn't appear again.
Do you think if you waited longer, more years, would the results be different?
Well, as I can see now, I'm not sure because the grasses are really bad in some plots, so I don't think they will go away just with time. So maybe an adaptive management would be necessary.
Okay, thank you. Okay, so our next, thank you. So our next speaker is Ana Flavia Boemi, who will be talking about, your slide should be coming up soon, sorry about that. Apologize. Sorry about that. Her title's up there, so I'm going to let you see.
Good morning. Oh, sorry. Good morning. My name is Ana Flavia Boemi, and I'm here to present you part of the results of my master that was advised by Professor Sergio Gandolfi at the University of São Paulo. And I'm going to talk about the distinction of the structure and floristic composition of an area in forest restoration process and another in natural regeneration. Well, restoration actions in general are applied to initiate or accelerate the recovery of degraded lands, and as the costs are high, the need for cost-effective restoration actions increase, as well the knowledge of when and where to use them. To understand, to plan, and to manage the interventions, the restoration actions, it is important to know about how the natural regeneration behaves in the certain site. And it is not always possible to compare the intervention's results with a secondary succession. But here we made this comparison. As well, our study's goals was to distinguish the floristic and structural parameters of two different sites in a forest-dominated forest landscape in southern Brazil. One was undergoing restoration process by the total planting seedlings method, and another one was undergoing natural regeneration process. Well, the study was performed in a forest garden of an energy company of the state of Rio Grande do Sul, in the municipality of Canela, northeast of Rio Grande do Sul. The climate is CFB. The annual precipitation is around 1,800 millimeters. And the local forest is a semi-deciduous seasonal forest that belongs to the Atlantic forest biome. And the landscape, as you can see here, is dominated by forests and mature forest. The sites in the past were eucalyptus stands that were harvested about 8 years before the study. And as an environmental compensation because of the understory that was suppressed, the company had to plant native tree seedlings in the opened areas. All the stands received the planting, but not in the total area of them. The farthest portions were abandoned, and the vegetation established only by the natural regeneration. I bought this picture to show you how the sites are arranged in the relief. Here are the road and the closer site. The planting method were closer to the road and farthest the natural regeneration, but the areas were side by side. Here's the landscape and the relief. And as the landscape is dominated basically by forest and small areas of family agriculture, the development of the vegetation was very expressive in both areas. And as you can see here is the picture of the inside of the planting area. That this is the good plot, and this is the worst that we found. Here you can see the canopy closure and the tree growth. And the remaining of eucalyptus stems and stumps. These are pictures of the natural regeneration area and the bad plots that we found, and the canopy closure. Well, for the data collection, we allocated 20 plots in both areas in which all individuals with DBH higher than 5 centimeters were measured for high DBH. And for the regenerating stratum, 2 square meter subplots were allocated in each plot, in which big plot, in which all individuals with higher than 30 centimeters were measured. All specimens were classified according to their successional categories and dispersal syndromes. And we calculated the floristic and structural metrics and the phytosociological parameters, as well the individuals' proportion in different successional categories and dispersal syndromes. We found for the tree stratum 60 species, while in the planting area, while in the natural regeneration we found 56, and the rarefaction curves showed a little bit variation, but the richness was not different, as you can see at the jackknife estimator. The main families were almost the same between the areas, and the indices of the Jacquard and Chow-Jacquard's indices showed that the areas floristic composition was similar. in both areas. And these are the mainly species that are almost the same. The difference were only in the order that they are arranged in the value, the importance value. And the density was not influenced by the site. As well, the basal area, the basal area were not different. The DBH distribution were not different as well, but the high distribution was different between the areas, showing higher highs in the planting area. The individuals' proportion in the tree stratum were influenced in the early secondary individuals' proportion, showing higher levels in the planting, while the climax individuals were higher in the natural regeneration. And the dispersal syndromes were also influenced by the site in the animal dispersed and wind dispersed species, showing higher here in the natural regeneration and higher wind species in the planting area. And now talking about the regenerative stratum, we found a little bit, we found the richness is a little bit different, as you can see in the species rarefaction curves. And the main families were also a little bit different, as well the jackknife stimator, but the Shannon's and Piolot's indexes were almost the same. And as well, the tree stratum, the similarity was the indexes showed the floristic composition were similar. As well, in the tree stratum, we saw the species were almost the same, but in different orders of importance value. But here, the density were influenced by the site, showing higher density in the planting area. But the basal area was not influenced by the site. About the succession of categories, there were influences in the early secondary individuals proportion and in exotic individuals, showing the first were higher in the planting area, and the second were showing that there were more individuals, exotic individuals in the natural regeneration. In the dispersal syndrome, they were also influenced by the sites, showing more higher levels of wind dispersed individuals in the planting area. And a little bit conclusions that we saw. In general, data showed no differences, significant differences between the sites. And in this context, the very favorable landscape and very good historical land use, the planting did not facilitate the forest restoration when compared in an area in forest succession in similar conditions. And then in this case, the natural regeneration was sufficient to initiate the restoration of the forest structure and the ecological process. But, however, some parameters were different between the areas. So we can say the planting interventions did not result in a greater diversity or species equability, but may generate differences that are advantage or not, depending on the project goals. And reinforcing what we are seeing in this Congress, a correct initial diagnosis becomes essential to choose the best restoration methods, which may decrease the restoration costs, turning it more attractive. And in other forest restoration that may be carried out in the same area or in the same region or in the similar areas, we should pay attention to the natural regeneration potential of the sites. And so it is. Thank you very much. Sorry about my English. And I want to thank you also to my team and to the University of Rio Grande do Sul that was helping. And thank you.
Do we have any questions?
Do you have any information about how different the regenerating areas are from the old growth forest?
I did not make this. I did not make this study, but there is a thesis of Milena Rosenfield, the state. Milena, are you here? No. That she compared the old forest with the planting areas. Milena Rosenfield is in the. I think it's almost in press, his article. But I did not this. What?
What did he find?
She.
She, sorry.
Oh, sorry, I was in her audience, but she found, Sandra, could you help me, please?
I am Sandra Miller from the University of Rio Grande do Sul, and I advise Milena Rosenfield. So she found that the species composition was still different, but in this site, Canela site, was the best one. So the areas were almost 10 years old, and many species already were there, and but other processes are still different, ecosystem process, such as decomposition and litter, and I don't remember very well, but Milena will present some results about that on Friday in the morning. Okay?
Thank you. Any other questions? No? No? Am I missing anybody? Okay, thank you.
Thank you very much.
Okay. We'll now go ahead with our last speaker. Oops, sorry, I have to put my glasses on. Up here. Our final speaker is Lourdes Gonzalez Soriaf, and she'll be talking about a study of the successional state of a degraded area in the Cerro Cora National Park, Department of Ambambe.
Good morning. I'm going to make my presentation in Spanish and hope someone can translate the questions and comments to me. I apologize for that. Ok, el caso de estudio es Successional State of a Degraded Area in Cerro Cora National Park in Paraguay, Inputs for a Future Actions. Ok, los cambios que se presentan en un área degradada y la velocidad con la que ocurren esos cambios dependen de la naturaleza de la perturbación y de las propiedades propias de ese sistema que se quiere restaurar, la resiliencia y la resistencia de ese sistema. Lo que buscamos fue determinar el estado sucesional de un área degradada, que es esta que ustedes están viendo aquí, incluyendo la descripción de su historia de uso y su historia de manejo previo. El Parque Nacional Cerro Corá tiene esta superficie que está en rojo, tiene 5.538 hectáreas en total, se encuentra en el departamento de Amambay, en la región oriental de Paraguay. Como ustedes ven aquí, un acercamiento, el área de trabajo donde hemos estado haciendo el monitoreo es esta zona que se encuentra aquí. Es posible ver que está circundada por bosques nativos. La temperatura media anual de la zona está entre 23 a 25 grados. La precipitación está entre 1.450 y 1.700 milímetros. Los veranos allí son húmedos y los inviernos son secos. Y tenemos por lo menos 2 heladas. Los suelos son franco-arenosos y areno-francos. Las formaciones vegetales son cerrado, cerradón, bosque subtropical semideciduo, bosque denso subtropical, bosque medio semideciduo subtropical, bosque en galería y pastizales. Es una zona de muy alta diversidad a pesar del estado en que se encuentra la matriz, que es una matriz agrícola y ganadera. En el mapa de relieve podemos ver la zona donde se encuentra el estudio. La formación vegetal en el área, específicamente en el área de estudio, es el bosque medio semideciduo subtropical y tenemos suelos con bajo tenor de materia orgánica. Para este trabajo se establecieron 4 parcelas de 400 metros cuadrados, se identificaron todas las especies presentes y los grupos ecológicos, se hizo una descripción del suelo. En la gráfica, en la imagen se puede ver la intervención que se hizo en el año 2011. Lo que se hizo fue laboreo del suelo con maquinaria para romper la compactación hasta los 30 centímetros de profundidad. Hubo una pequeña plantación en un sector al inicio de esta pista de aterrizaje de 200 individuos de especies propias del bosque atlántico del Alto Paraná, de la Mata Atlántica, pero apenas hubo una supervivencia de 30% en el primer año. Esta zona había sido utilizada como una pista de aterrizaje desde la creación del parque en 1976. Recién en 2011 se hace esa intervención y en el segundo año y tercer año lo que podemos ver es el área de plantación con casi nada de supervivencia de los individuos instalados. Bueno, existen factores que afectan el proceso de sucesión, algunos son limitantes, otros factores tensionantes y algunos factores persistentes. Lo que podemos ver aquí son las situaciones en el año 2015 en dos de las zonas de trabajo. Como ustedes ven, no ha habido mucho cambio desde la intervención. En esta otra imagen vemos una zona de suelo muy compactado, son tomas del año 2015. Con el IST le definen el modelo de sustitución de especies en la sucesión, pero también, tienen indicando que hay 3 procesos clave para que eso ocurra. Inhibición, facilitación, pero también hay otros procesos que asisten, que a veces causan retrogresiones y también otros factores que hacen que el proceso no sea tan mecánico, como que la facilitación y luego la sustitución por las especies de los estados más avanzados del ecosistema. La reproducción y el establecimiento, así como el crecimiento y la mortalidad, son procesos que definen la dinámica y la estructura de la población. La dinámica y la estructura resultante de la población. Estos factores se encuentran directamente relacionados con cambios en la estructura de la comunidad. Las condiciones consideradas o los criterios considerados para el desarrollo, para el análisis del proceso de desarrollo sucesorio en esa zona degradada han sido el tipo de disturbio, el ambiente físico, suelo y los parámetros climáticos, los sitios disponibles para la colonización, la disponibilidad de propágulos provenientes de vegetación remanente y el síndrome de dispersión de las semillas han sido claves en este estudio, la habilidad de las especies para establecerse, y eso tuvimos solamente en cuenta el grupo sucesional al que pertenecían esas especies, los factores bióticos de inhibición post-establecimiento de las especies, y en ese sentido vimos competencia por recursos y alelopatía. En términos de disturbio, hablamos de desbaste total, de factores persistentes y periodicidad. En relación a la periodicidad, podemos decir que los fuegos que venían ocurriendo ya no fueron ocurriendo porque ya no ocurrieron porque el área fue aislada. En relación a los parámetros del sitio a colonizar, a los parámetros físicos del sitio a colonizar, vimos la complejidad, la disponibilidad de nutrientes en el suelo y la estabilidad climática. Algunos resultados intermedios: vemos que existe una comunidad vegetal circundante que provee propágulos, y también existen elementos de fauna que dispersan esas semillas, existe un bosque de referencia, un ecosistema de referencia, pero sin embargo no está habiendo éxito en la colonización por las especies. Vemos, por ejemplo, que hay fauna que dispersa las semillas del ecosistema circundante y, sin embargo, luego de las acciones en las que se esperaba que el proceso de facilitación haga que las especies pioneras llegaran al sitio y modificaran esas condiciones para adecuar el sistema para la entrada de especies de etapas más avanzadas, no se ha visto en estos 6 años un proceso de modificación hacia un estado más avanzado del ecosistema. El cambio en las condiciones abióticas y bióticas durante el proceso de sucesión, sabemos, debe provocar modificaciones tanto en la dinámica y en la estructura de la población como en la composición de las comunidades. Sin embargo, nosotros tenemos solamente estas 11, disculpen que desde lejos no veo con lentes, tenemos estas 11 especies, Dugetia furfurácea, que es una especie secundaria inicial, Pyrostechia venusta, que es una pionera, varias otras pioneras como ustedes ven aquí, Eugenia bimarginata, afín bimarginata, que es una secundaria inicial, que es una de las más complejas, y la especie dominante, que es Digitaria sp, que es un pasto que es bastante agresivo, que ha tomado casi todo el espacio de la pista de la zona degradada. Hemos encontrado estas barreras abióticas. La primera barrera es la compactación del suelo, que a pesar que se rompió la camada hasta 30 centímetros de profundidad, no ha conseguido proveer las condiciones, bajo contenido de materia orgánica, que no ha podido ser complejizado. La barrera 3, bajo contenido de nutrientes en el suelo. En relación a las limitaciones bióticas, especies de carácter invasivo y especies de carácter inhibitorio. Esta es una especie nativa, solamente es para amenizar la diapositiva. Es una de nuestras especies estrella, Dugetia furfuracea, y es una especie del cerrado. A pesar de que tenemos bosques semideciduos, tropical semideciduos en los alrededores, también tenemos cerrado y cerradón, y las que están colonizando, traídas por la fauna, son más las especies del cerrado. Otros resultados, bueno, en resumen, 11 especies fueron encontradas y todas son herbáceas o arbustivas. La especie dominante es Digitaria sp, como ya les dije. Hay limitaciones abióticas que ralentizan y detienen el proyecto de sucesión, el proceso de sucesión secundaria. Y el área evidencia problemas de infiltración, de compactación, escaso contenido de materia orgánica, que hace que muchas especies lleguen pero no prosperen. Hemos visto algunas llegar y no prosperar ni aumentar en sus poblaciones. Tenemos especies dispersadas por fauna. Y finalmente encontramos o compartimos esto como un aprendizaje de demasiado tiempo, de poca inversión tal vez, pero como una prueba de que la restauración pasiva en algunos casos no resulta, aun cuando se tenga ecosistema de referencia circundante muy cercano, porque es el caso de esta zona degradada. Hay circundando la zona degradada un bosque en buenas condiciones, tenemos un bosque secundario y un bosque bien conservado también, y hay zonas de cerradón que están bien conservadas, y sin embargo no hemos visto que la dinámica de la sucesión se presente como se esperaba, solamente con facilitar con la remoción del suelo y esperar que el ecosistema circundante de referencia proporcione los propáulos para que el ecosistema se vuelva a su estado lo más cercano al original. Al contrario, lo que vemos es una especie de involución, o tal vez no es la palabra correcta, lo que vemos es un cambio a otro tipo de ecosistema, y probablemente debamos a partir de ahora implementar otras acciones más agresivas de preparación de suelo, o tal vez pruebas con nucleación como la que hemos visto en estos días. Las condiciones abióticas y bióticas condicionan la dinámica y ralentizan el proceso de complejización del ecosistema, y si las condiciones del suelo y la presencia de especies invasivas o de carácter invasivo no cambian, la composición de la comunidad no va a cambiar con el tiempo. Muchas gracias.
Okay, do we have any questions? No? Okay, well, maybe since it's getting to lunchtime here, we'll, if people have questions, they can come up and ask
Thank you.
personally. Okay, and so now, thank you everybody for coming to the session, and we'll hope you have a good lunch.